Hello everybody and welcome to lesson 12 going over array lists. So you've learned a lot so far this semester that has added tools to your Java toolbox and allows you to solve more complex problems and write more complex programs. First we learned about just basic execution of a Java program, how to print stuff out to the screen, the main method, what it does. Then we learned about expressions and variables, ways to save and use data in your programs. You learned how to do calculations and even more complex calculations with the math class. You learned about conditional statements and how to help your programs make decisions about whether or not to take a particular course of action. And you learned how to do loops and how to repeat actions in your programs and how to process data very quickly and efficiently. Now we're going to learn about collections and how to store data in a collection so that we can keep track of a large amount of things in your programs. We can put those things in order, we can pull them out of the collection when we need them, and the first collection we're going to learn about is the array list in Java. An array list is an object that helps us store other objects, and an array list is a great example of what we call abstraction in programming. And what abstraction is it's the process of hiding the implementation details, so how an array list actually works under the hood and what the people who wrote the array list class had to be concerned with, and hiding those details and only caring about the interface, the way we interact with an array list, that being the methods that the array list object has to offer. So rather than being concerned with how an array list actually stores the objects that we're putting in our array list, we only need to know about the different methods of the array list class that allow us to interact with that collection of objects. We have methods to add objects to that collection, add them into a certain position or index in that collection, how to pull objects out from a particular index in the collection, and how to actually remove objects. So one way of pulling an object out is to get the object, so to actually return the reference to it, so that we can interact with the object in the collection. And then you've got actually remove methods that actually take an object out. And so that's abstraction for you at a very basic level, just hiding the implementation details and thus only caring about how to interact with it. Really underneath an array list is an array, which is another data structure we're going to learn about at the very end of the semester. And with those, you actually have to care about the size of your array. You have to know when your array ends so that you don't accidentally cause an exception. Array lists are awesome because we can just add objects to that array list all day long and it'll just continue to accept them. So we don't have to be concerned about the size of our array list, how much space has been used or how much space is left. All we have to do is add and remove objects to interact with that array list. So let me go over just a couple basic examples of how to create an array list and how to use it. The first thing you got to do when you want to create an array list to store objects is, just like every object in Java, we have to declare and instantiate our object. So an array list declaration looks like this: camel case, capital A, array, capital L, list. The other thing, and this is something that you won't have seen before, are the generics here. And when we say generics, we mean the open, I guess you could call that angle bracket, open angle bracket, close angle bracket. And inside of those goes the type of the object that you're going to store in the array list. So not only do you have to declare, hey, I want an array list, you actually have to tell Java, I want an array list that's going to hold this type. So in here we could put color if we want to store an array list of colors. We could put integer if we want to store an array list of integers. And here's the thing, is notice that this is capital I integer. We've done capital I, lowercase I, int, num, all the time. We've done integer declarations. We've never seen this capital I integer. What this capital I integer is what's called a wrapper class for the primitive type int. So if we did like int num equals 5, I'm just going to leave that up there. Notice that this type is different, integer is different than this integer. That's because array lists can only store objects. They actually can't store primitive types. The reason for that, I think, being that an array list really stores object references. So again, just pointers to that object, like we've discussed in the past. And so the array list doesn't actually hold any object values. It just holds the reference to those objects. And I think that was decided to help kind of standardize the implementation of the array list. So the creators only had to worry about storing object references. They didn't have to worry about storing all different actual kinds of values. And so whenever we want to store a primitive type in an array list, like int, double, char, we use the primitive type's wrapper class. And what all that does is it just automatically creates an object of type capital I integer to store our primitive type integers. And when we pull the objects out, they actually get automatically what we call unboxed into a primitive type and automatically boxed when we put them into the object type. So just be aware of that array lists can only store objects. So if you're putting a primitive value into it, you have to use that primitive's wrapper class. And if you look at the documentation here, it says the capital I integer class wraps a value of the primitive type int into an object. An object of type integer contains a single field whose type is int. So all it is just an object that holds an integer value. So I'm going to create an array list here called numbers. Again, we told it what type of object we put into it here. I'm going to initialize my array list on the same line, so use that new operator, new cap array list. And here's another thing to be aware of is all of our slides, and I believe the book still tells you to put capital I integer here and use the generics again on the constructor call. Also going to go ahead and import ArrayList. Notice it's in that java.util package, so yet another class we're using from that package. We have our generics again here on the constructor call. Notice we've already put them on the type. This is a big complaint people have with Java, that it's too verbose, meaning we have to write out too much information that's actually extra that we don't need. The new operator is a perfect example of that. Why can't we just call the constructor? Why do we need the new operator? I don't know. It's a Java thing. But these repeated generics is something the creators of Java actually addressed in later versions. I don't actually know what version they stopped being required, but you can actually just have an open diamond operator, close diamond operator. And we do call that generics or the diamond operator depending on who you talk to. We've got a warning here from actually deleting it, so we do have to just have those empty. But what I think this says really is just use the generic type that's already been declared here. And so just know that you can do this. It's perfectly valid. I encourage you to do it because, again, let's be lazy. We're programmers. We don't like to type things over again. So that's one thing that you can omit here. So we've got my int num. We can go ahead and do numbers.add num. And let's do another num, and we'll do numbers.get 0. And I'll print it out and show you that our num, when we add it, gets turned into a capital I integer automatically. And we get it out of our array list, it automatically gets unboxed into a lowercase I int. And we can print it out and everything works just fine. We got our value 5 down there, you can see. So that's the generics, the auto boxing and unboxing. Just remember that it's always important to put the type there of the object that you're going to store in your array list. You can only add objects of that type as well. So if we add double, if we tried to add our decimal value, notice we get a complaint here. The method add integer in the type list integer is not applicable for the arguments double. However, if we change this to double, we also get the issue of adding num to it. However, you can add a cast to turn num into a double, and it's happy because remember 5 doesn't have a decimal point on it, so we can easily turn that into a double. If we kept this as an array list of integers and we added a cast to int here, and we were to get the object at index 1, notice that when I run this, we lost the decimal point on 10. So you have to be very careful about the types of things you're adding into your collections. By casting decimal to an int so we could add it to our integer numbers, we actually lost precision. We lost the decimal point on our double decimal that we declared up here. So better if you're storing a list of numbers and you have to store decimal points and floating point numbers and integers, best to just declare it as an array list of doubles so that you don't lose any precision on your floating point numbers. So that's something to be aware of as well. Also notice that this behaves just like a string. The indexes in your array list start at index 0 and go 1, 2, and 3. You can actually print out the size of your array list, and it works the same as strings do, where the size of numbers is 1, but there's the index of that first value in numbers is 0. So if the size of your numbers is 1, then you've only got index 0. So that's also something to be aware of. If we did system.println and we printed out numbers.get, the size of numbers, this is going to cause an exception. Java index out of bounds exception. So here, we've only got one object in our array list, so the last index is 0, but the size of our array list is 1. So when we tried to get something out, there is no index 1 because we only have index 0. And so whenever we're getting something from the end of our list, we always have to put size -1. So in this case, that gives us size is 1, -1 is 0. That gives us index 0, which is the first and last index of our array list numbers here in this example. So again, be aware, just like with strings, you always have to do, if you get something from the length, like if you did char at string.length to get the last character of your string, you also have to subtract 1 from that, just because we're indexing from 0. But size is 1 index, because it doesn't make sense to 0 index the size of something. Now let's go over how we can view the contents of our array list. I'm not going to go over the remove or add at index methods. The supplementary videos provided in the assigned reading, I think, touch on that, as do the slides. The slides for this lesson are an excellent resource, so I definitely recommend going over those. So I'm just going to jump right into actually printing out the contents of our array list, and then how to iterate over the contents and actually do something with the different values in the array list. So I'm just going to go ahead and add a bunch of numbers to my array list. Notice that you can add just integer literals. So I'm going to add 3 values here. And I briefly mentioned toString in the Project 1 intro. I highly recommend you go watch that, even though Project 1 is due Tuesday night. You've probably already watched it. If you need a refresher, objects always have a that are written in Java usually have a toString method, which represents your object as a string. And so for array lists, the toString method that gets called when you print out your object prints a comma-separated list of the values in your list. And since those are objects, that actually calls toString on those values as well. So you get a listed string representation of everything in your list. What that means for our list of numbers is actually we get this. And you're actually asked to do this in the activity for lesson 12. So you notice we print it out, and we have our square brackets, which are generally the notation we use to show that something is a list. And then we've got 5, 15, 12, nice little comma separated list of values there. So you can easily see what's inside your list. Now I want to go and actually print out the individual values in our list, comma separated, but I don't want these square brackets here. I want it to be nice and clean. And so with this example, I'm actually going to talk about, number one, how to do that, but number two, how to use different types of loops to print out the things in your list. So the first type of loop I want to go over is just your standard for loop. So I'll go over the ones we've discussed already, and then I'll go over the last new kind of loop that we're going to talk about in this lesson. So this is really cool, is we need to visit every index in our array list here. So since we have three integers in our array list, we've got index 0, index 1, and index 2. So the size of our array list is 3. Our last index is 2. So if we iterate, when I say iterate, it means we visit every index of our array list. While we iterate over our array list, we're going to iterate up until I is less than numbers.size, which means the last index we're going to visit is less than 3, which is 2. And so this less than size is going to be something you'll use a lot whenever you're iterating over array lists, because if you start 0 and go to less than size, you're going to visit every index in that array list. And we've got that get method on numbers. And so because I is going to be the value of the current index number that we're at, we can simply print out numbers.get, well, if I could type, I. So let's try that. And nice. So we've got, and we did a print line here, so we are printing them out all on separate lines. Now if I wanted to print them out comma separated, I could do this. Nice comma and space there. I'll change this to print. So that's nice, but we have a trailing comma. And so something we can do for that is just use a simple if statement. So if I is, this is the last index we don't want to have a comma. So if we're not on the last index, print it with a comma, else we'll just print numbers.get I. Now this is the first thing that occurred to me. It could be that there's a better way to do this. So if you do, feel free to hit me up because I would love to hear it. But I'm just kind of winging this while I record the video, so I'm going to keep it simple, do the first thing that comes to mind. So now we're printing out a comma if we're not on the last index. If we are, we're going to just print out the value without the comma. So this is how you would get the different contents of the loop at each index inside a for loop. Again, it's really nice that we have this variable I, because that gives us the number of the index. So we can easily use the get method to get each object at each index and print it out. So for loop works great. I want to use now a while loop. And I'm also going to do something that we discussed in a previous lesson, and that is I'm going to create an iterator. We talked in previous lessons about how an iterator is an object that helps you process a collection by giving you each object in that collection individually. A scanner is a good example of that, where a scanner can scan over input. We're actually going to do that in next lesson, lesson 13, where we scan over a file. With ArrayLists also have iterators, and they can occasionally be helpful with processing the items in an ArrayList. Now, I wouldn't recommend doing this usually. Usually a for loop is going to be, or for each loop, which I'm talking about next, is going to be a better solution, but iterators can be useful occasionally. And there's actually a method in an array list that gives you the iterator for that array list. Iterators work a lot like an array list, and that they have generics. So the first thing I have to do, if I'm going to get an iterator object, is I have to declare it, as always. So I've declared an iterator here, and it's going to be an iterator that iterates over integers. So I do have to tell my iterator what type of object it's iterating over. And I'm going to set it equal to numbers dot iterator. Returns, in this, you can see in the little docs here, it returns an iterator over the elements in this list in proper sequence. And so, oh, and I forgot to give it a name. That's why I was confused. I'm just going to call it. Notice it's red here. I do actually have to import iterator, again, from java.util. So usually, if you can't decide which one to import, the shorter package name is the one you want. So util is what we're going to use here. That looks like there was another iterator we could have imported. And the iterator actually has a method, just like our scanner does, called hasNext. So while it.hasNext, which means there's going to be a next item in our list, we can continue to iterate. Of course, if we just went over and iterated over the last object in our array list, there's not a next object to iterate over, and this will return false. And so we actually are just going to get rid of this if statement here for this one, because it's a little bit difficult we'd have to create a counter variable to determine if we're on the last and next to not print a comma. I don't really want to do that. So I'm just going to go ahead and print line it.next. And the next method is how you pull the next item of input out of your iterator. With the scanner, we use that to get the next token in the input that was provided. And so that should seem pretty familiar to you. So if we run this, you can see we can print out all the different objects, and our list stops when we reach the last one. One thing you can't do, though, is once you create an iterator over a list, you cannot actually modify the list. So if I did numbers.add and just added a number in here, when we run it, we'll actually get a concurrent modification exception because we modified the list while our iterator was iterating over that list. We'd get the same exception if we removed an object. We can mess around with the objects in the list. We can call methods on the object. So I could do numbers.getZero, or even numbers.set index 0 to 15. And actually, let's set index 1 to 20 here so you can actually see it change. So notice index 1 is 20. That's fine. We can actually change the objects in our array list, but we cannot add or remove objects from our array list. And last but not least, there's also a third kind of loop you can use, and this is my favorite. It's this new type of loop we're going to learn about called a for each loop. And it's really useful to use whenever you want to iterate over all the objects in a collection. The syntax it's similar to a for loop. The syntax looks like this. And before we do anything, I'm just going to run this. Notice that we print out every integer in our array list. And this is what's really cool about for each loops. They're called for each loops because of the way you can kind of read the syntax. I like to read this as for each integer I in I'm trying to highlight the colon, in numbers, do this thing. So again, for each integer I in numbers, do the body of the loop. What happens is we say here what type of object is in our collection, and we get a little placeholder variable. So you can, this I, every time through the for loop becomes the object at the first index, the second index, the third. It actually is a reference to that object. Excuse me. So we can get I, the first time through the loop, is 5. Second time through the loop is 15. Third time through the loop is 12. And then the loop doesn't go again. So the for each loop automatically just iterates over every object in the collection. So it's going to run from the beginning of the list to the end. And again, I like to read this for each integer I. So there's a type, there's a little placeholder in, that's how I think of the colon, numbers. And then that's the name of the list we're iterating over. So we can print out each object in the list. Now you can do this, but notice if I were to just set I equal to 5 and then print out my list at the end, notice that the contents of the list aren't changed. So I is just a reference to the integer, the first integer, second integer, and so on in our list. So if we set it to a different value, we're actually just creating an alias for I, and it no longer points to the integer I at that position in numbers, it just points to this object 5. But then, the next iteration of the list, again, I is going to be a reference to the second number in our list, and so on. And so that doesn't actually change the contents of our list by doing that. So again, for each loop's super handy when you just want to visit every index in your collection. You don't care about stopping at a certain point and don't need like a counter variable that like I in our original for kind of style for loops that represents an index number. For each loops are super handy, and you'll see that I think in our activity. So with that, let's get to that activity, everybody. I'll catch you later. Happy coding.